guys, today's lesson is solving exponential equations and inequalities. The rule is that if bases are the same, our exponents are equal. In problem number 1, we have a very basic example in which the base of each side of the equation that's being raised to an exponent are the same. Both sides of the equation has a base of 2. Therefore, the exponents are equal, in which we get our solution, x equals 6. The number 6 will solve the equation 2 to the x power equals 2 to the 6th. If you plug it in, we'll obviously have 2 to the 6th, which is equal to 2 to the 6th, which is true. Therefore, it's a solution to the equation. The following problems will not have the same bases, in which before finding our solution, we must find the same bases or make both sides of the equation have the same bases, and then we could set our exponents equal to each other. For example, problem number 2, as you could see, the left side has a base of 2, and the right side of the equation has a base of 8. Can we make these have the same bases? I know that I can make 8 have the same base as 2, since 2 to the 3rd power is equal to 8. So we could rewrite this equation as 2 to the x equals 2 cubed, which is 8 cubed. I'm going to simplify, and if you remember a couple chapters ago, we were talking about the power property. When you're raising a power to a power or an exponent raised to another exponent, we're going to multiply them. Therefore, this will simplify to 2 to the x power equals 2 to the 9th. Now that our bases are the same, both sides have a base of 2, our exponents are equal. Our solution to the equation is x equals 9. Moving on to problem 3, very similar to problem 2, where we're going to change one of the bases to match the other. I know that I can make them both have a base of 3, since 3 squared is 9. So I'm, instead of 9, replacing it with 3 squared to the 2x minus 1 power equals to 3 to the 6x power. I'm going to simplify the left side by distributing the exponent 2, in which we'll have 3 to the 4x minus 2 equals 3 to the 6x. Now that both sides have the same base, we could set their exponents equal to each other. We will have the equation 4x minus 2 is equal to 6x. Solving now this equation, going a little bit further than problem 1 and 2, we'll have to subtract 4x on both sides, leaving us with negative 2 equals 2x, then dividing the 2 to get our final answer of x equals to negative 1. Problem number 4, I could change 64 to have the base of 4, since I know 4 cubed is equal to 64. So our new equation will be 4 to the 2n minus 1 power equals 4 cubed, since 4 times 4 times 4 is 64. Now that they have the same exponent, or the same bases of 4, we could set the exponents equal to each other. Solving our equation, adding 1 to the right and dividing by 2, we'll get our answer n equals 2. What I'm going to do is ask you to try problems 5 and 6 on your own. Once you get your answers, play the video back to check. Here are your answers to problem 5 and 6, where 5, we could make both sides of the equation have a base of 5, distributing the 3 times the x plus 2, since 5 cubed is 125. We get 5 to the 3x plus 6. We could set both exponents equal to each other and solve to get our solution, x equals 3. Problem number 6 isn't an equation, it's an inequality, in which we will solve the same way. In order to make them both have the same bases, you actually had to change both of them to both have a base of 2. Since I know 2 to the 4th power is 16 and 2 cubed is 8. Setting the left side less than or equal to the right side, or the left exponent less than the right exponent, our solution is the fraction 15/8. But specifically, it's an inequality in which our solutions are every number less than 15/8. Continuing on with the first page, we'll finish up with problems 7 and 8, as where you could see we have both inequalities and a fraction. 1 over 243 we can make into a base that's not a fraction to a negative exponent. Our new inequality would be 3 to the 2x minus 1 is greater than or equal to 243 to the negative first. A couple chapters ago, we learned how to make negative exponents to positive exponents. Here, since we have 1 over 243, I could rewrite that so it has a base of 243 to the negative first. We now have to figure out how to make both sides have the same base, in which we could have them both be the base of 3, since 3 to the 5th is 243. So we'll have 3 to the 2x minus 1 is greater than or equal to 3 to the 5th to the negative first. We're not going to set the exponents equal to each other here. We're going to set the left one greater than or equal to the right. So we'll have 2x minus 1 is greater than or equal to negative 5. Adding the 1 and dividing the 2 will give us our final solution as x is greater than or equal to negative 2. Similarly, problem number 8, I could rewrite 1 over 32 as 2 to the x plus 2 power is greater than 32 to the negative first. That will help us create the same bases on both sides of the inequality, since I know 2 to the 5th is 32. So we'll have 2 to the x plus 2 is greater than 2 to the 5th to the negative first power. We'll set the left x, since we now have the same base on both sides, we'll set the left exponent, x plus 2, greater than negative 5, and subtracting 2 on both sides will give us our solution, x is greater than negative 7. Our last page for our lesson today is writing an exponential function, in which they will be in the form y equals ab to the x power, where a is our initial value, or y-intercept, and b is the change, or our change factor of the exponential function, whether it is increasing or decreasing. What they're going to give us is 2 ordered pairs for each problem, in which the first ordered pair, for example, problem number 1, 0, 4, is your initial value, and a second ordered pair would represent an x and a y value. What we're looking for is the change, or the exponential factor for the exponential function, and then we could write our exponential equation or exponential function. So what we're going to do is plug the initial value in, plug in x and y, and then find out what b is. So we're going to have y equals ab to the x. In this case, y is 36. A is the initial value of 4. Remember, an ordered pair is the x and y value. X stands for time, and y is the value at the time of 0. So it's your initial value. We're looking for our change, or exponential factor, and x is to the second power. We're going to start by solving for b by dividing 4 on both sides, leaving us with 9 equals b squared. Further solving for b, we'll square root both sides, leaving us with b equals to 3. Now that I know what the change or the exponential factor is, we could write our exponential function y equals our initial value of 4 times the change factor 3 to the x power. In this case, since our b value or our exponential factor is positive, this exponential function, if graphed, would be increasing at a very quick rate. Moving on to problem number 2. Again, they're giving us our initial value, so our 6 is going to be our a, and another ordered pair representing an x and y. We could use these to find the change or the exponential factor in y equals ab to the x, and then use it to write our exponential function. In this case, our y is 81, our initial is 6, we're looking for what b is, and the x value is 1. In this case, we're going to divide both sides by 6, in which 81 divided by 6 is 13.5, leaving us with b to the first, or just b, is 13.5. Once you find the exponential factor, or the change, we're going to then write our exponential function by plugging in our initial, which is 6, and our change factor, which is 13.5, to the x power. What I'm going to ask you guys to do is try number 3 and 4 on your own. Once you get your answers, play the video back to check. Here are your answers from problem 3 and 4. Problem number 3, we're left with 64 equals b to the 6th, in which you want a 6th root both sides. The 6th root of 64, or the number times itself 6 times, which is 64, is 2, in which we could then write our exponential function. Similarly, problem 4, we're left with 243 equals b to the 5th. If we take the 5th root of both sides of the equal sign, we would get that the number times itself 5 times to get 243 is 3, in which our exponential function is y equals 2 times 3 to the x power. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.